This lesson is about compound and absolute value inequalities. So you learned about inequalities before, and so you know things like x is greater than 2, and we graph it on a number line, open circle, going that way. And so we're going to talk about when you have more than one inequality at a time. And then as a little prerequisite for absolute value inequalities, we need to talk about absolute value equations. Now we've graphed absolute value equations, but let's talk about what that is and review the idea of absolute value. If I say that the absolute value of x, so the absolute value of some number that I don't know, is equal to 5, think about what that means. Okay, so you've got the absolute value of some number is 5. That means that whatever number it is, it's 5 away from 0. So what is x going to be equal to? So you say, well, of course, x is equal to 5. That's true. X is equal to 5 because it's 5 away from 0 on the number line. Is there anything else that's equal or 5 away from 0 on the number line? Yeah, there's actually negative 5 also. So actually there's two solutions to this equation, and that's going to be x equals 5 and negative 5 also. Okay, so that's two solutions. So when we have an absolute value, and let's graph that. Remember from graphing, we said that it's going to be, like this. When is the absolute value equal to 5? Well, if I come up here on the x-axis or the y-axis, if I go up here to 5, it's equal to 5 right here at positive 5 and also at negative 5. And that's what we're saying. We're saying when is it equal to that? So let's kind of do another one real quick. And so if I say something like x plus 2 is equal to 6, what does that mean? It means that this number right here, when I take the absolute value of it, it's going to be 6. So that number inside is either positive 6 or it's negative 6. Both of those would work. So if the inside is negative 6, then the absolute value is positive 6. And if the inside is 6, then the absolute value is also positive 6. So now if we solve these equations, I would solve each one. So I'd get x is equal to positive 4. And then this one, I would get x is equal to negative 8. So what that means is that if I was to graph this, remember that the plus 2 translates our graph to the left 2. So that's where my vertex is. And then we're going to have this coming up like this. This means that when x is positive 4 and when x is negative 8, sorry, it's not exactly to scale. What that means is that is when, well, like I said, it's not exactly to scale. That's when our absolute value is equal to 6. And so that's what that's saying. There's also a situation when we might have something different come up. Like what if I say the absolute value is equal to negative 4? When is the absolute value of a number equal to 4? So what number is negative 4 away from 0 on the number line? So if you think, well, it's negative 4, so let's ask this. If I plug that in for x, and I say the absolute value of negative 4, is that equal to negative 4? It's not, because no absolute value is equal to a negative. So what that means is it means that there's no number that I can put in for x that's going to work. Nothing is going to work. So this would be an example of no solution. There is no number that has an absolute value of negative 4. And so when we have absolute value equations, it is possible to have no solution. And what that means is if you were to look at the graph, if I have, this absolute value graph that looks like this, when is the absolute value graph equal to negative 5? Well, it's never equal to negative 5. There's nothing down there. It's never going to happen. And so that's what we're talking about there. Okay, so moving on, we're going to start out with some compound inequalities. And so numbers 1 through 4 on your paper, we're going to pause the video and you are going to do 1 through 4. So you're going to graph two inequalities on the same number line at the same time. So just do 1 through 4 right now. Okay, for number 1, you just need to make your number line. And so the first one says x is less than negative 4. So I'm going to put an open circle on negative 4. I'm going to go to the left. And so all of those numbers are less than negative 4. Okay, now x is less than 2, open circle, and I'm going to go to the left again. So that's kind of like two problems in one, but this one it says and. So what I'm asking you is, when are both of those true? When is a number both less than negative 4 and at the same time it's also less than 2? Well, that happens over here. That's when that happens. So basically, anytime your numbers are less than -4, that's when that's true. Now, you don't have to write anything for that if you're just graphing it, but what we do need to see is we need to see this overlap. So you need to like somehow shade it in or show me. So if you do like a really thick line right there, that's fine. But I want to see that you had two distinct inequalities to start with. So in number 2, again, if I say this is -4 and I say less than -4, we're going that way. And then what if I say less than 2? But this time it says or. Okay, so if it says or, I'm happy either way. So I'm happy if it's less than 2, and I'm happy if it's less than -4. So basically all of these are going to be solutions because all of those are going to work. So what I'm really going to have is I'm going to have anything less than 2 is going to be my solution. Okay, the next one, -4 again, so less than -4. And x is greater than 2. Trying to color code here. Greater than 2. Okay, so it says and. So when are they both true? When is a number less than 4 and at the same time greater than 2? Okay, that's never true. So this would be like a no solution situation where that's never true. And then the next one, -4, and then it says or greater than 2. So I'm happy either way. I'm happy if this happens. I'm happy if this happens. And so I have multiple things that it can say, but it can't be both at the same time. So when we solve inequalities, compound inequalities, we have to be aware that there's going to be a range of solutions. So one of the strategies that is really good to use is we write these as two separate inequalities, and then we'll solve and graph. So when I look at number 5, it says -2 is less than or equal to k divided by 2 is less than 3. This is called a compound inequality because it's basically one inequality and then another inequality. So we're looking at two different things, and so it's compound. So one of the strategies is to write it as two inequalities. So we're going to start out, -2 is less than or equal to k divided by 2. Now, since it's compound, that means and. Okay, if it looks like that, it means and. So we're going to say and. So whatever happens has to happen at the same time. Now you're going to solve each inequality. So on the left, we're going to multiply by 2 over 1. So we're going to have -4 is less than or equal to k. And that's one of my solutions. And then over here, we're going to have k is less than 6. That's the other solution. Now you need to put that on the number line so we know what's going on. So we're going to have -4 and we're going to have positive 6. So -4 is, let's look at it, we've got to start out with k. So k is greater than or equal to -4. So we're going to say open dot, fill it in because it's equal to, greater than is that direction. And then k is less than 6, we're going to have an open dot, and we're going to go that direction. Since it says and, when is it both? It's between those. So the way I'm going to write my solution, I'm kind of short on space here, but the way I'm going to write my solution is I'm going to write k, actually we won't worry about set notation right now. We're going to say k is going to be between. So it's between 6 and it's between -4, and it's both at the same time. You're still going to have your signs and everything pointing the right way. So what this says right here is this says what this graph says right there. And that's how you would write that. Okay, let's go to the next one. Clear everything off so we have more ability to focus. I'm going to again write this as two separate inequalities. So I'm going to write 40 is less than or equal to -5a. And then I'll write -5a is less than 45. And then we're going to solve each of them in turn. So I'm going to divide on the left. I'm going to divide by -5. So remember that when we have inequalities and we divide by a negative, we have to flip our sign. And then write that starting from a. So that means that a is less than or equal to -8. So that's part of my answer. Okay, now I'm going to go to the other one. Divide by -5. So again, I have to flip my sign. So a is greater than, and that will be -9. So if I take these two inequalities, this and this, I'm going to put those on the graph. So let me do my blue one. So I'm going to have -8 over here. going to have a colored in dot, and it's going to be less than, so we're going to go that direction. The green one, actually, I think looking at all this, I better change some things. So I'm going to have -8 over here, colored in dot, less than going that way. And then the green one, -9, going to have an open dot going that way. Now again, because this is a compound inequality, it has to be both at the same time. That's why it's written like that. And so where does that happen? It's happening right in between. So when our number, A, is less than or equal to 8, and at the same time it's greater than -9, that's my solution. Whenever you write a compound inequality, you're always going to have the arrows pointing this direction because you're always going to have your numbers in number line order. So the smaller number will be on the left, the larger number will be on the right. That is the way it works. Do not write it any other way. You have to write it in number line order. Okay, let's go to the next one. These next ones are not written as compound inequalities. They could be, but they're written as two separate inequalities. And that kind of helps us to get started. We're going to solve this inequality, and we're going to solve this inequality, and we're going to graph it, and then we're going to talk about what that means. So pause the video and solve each inequality, and then graph it and see what happens. Okay, so when you solve it, you get n is less than 12 and n is greater than 15. So when you put that on your graph, you're going to have this. So when is that true both at the same time? When is a number less than 12 and at the same time greater than 15? That never exists. So there's actually no solution to this one. So we can write it like that, we can write it like this, or we can write out no solution. Since the other ones are not written in set notation or interval notation, probably just writing no solution will probably be a good choice for right here. Okay, let's do number 8. So pause the video again. Let's do number 8. Okay, so you get x is less than -3, or, okay, this is an or. That means I can be happy multiple ways, okay? So when I have an or, that's a different situation. So I'm going to graph my -3, less than -3 like that, and my 4 greater than like that. I'm happy if I have a number less than 3, or if I have a number greater than 4. So that means I can be happy this way, I can be happy this way. And so my solution is kind of multifaceted. So we can say x is less than -3 or x is greater than 4. Either way is fine. So that would be my solution. You cannot write, if it says or, you cannot write it as a compound. You can't write it as something like this. Okay, so that's only for and. If it says or, you cannot write it like that. Okay, just to review a couple of things about absolute value. So absolute value means the distance from 0, and it is never negative. So remember that absolute value is never negative. So tell me what number or numbers have an absolute value of 10. What numbers are 10 away from 0 on the number line? There's 2 of them. What number or numbers have an absolute value of more than 6? So what has more than 6? So does 6 have an absolute value of more than 6? No, but 7 does. So 6.1. How about 13 or 27? Okay, so we can have basically anything more than 6. So I'm going to say any number more than 6. Now, is there any other number that would have an absolute value of more than 6? And so if you stop and think about the other end of the number line, also any number less than -6. So like -6.1, -7, -42. Those all have an absolute value greater than 6 also. Okay, before we do number 9, I want to talk about an idea that we have to deal with absolute value inequalities. If I think about this as, let's just say if that was x, and I want to know when is the absolute value greater than 9, if I have 9 over here and -9 over here, it's going to be greater over here, and it's also going to be greater there. Okay, so this would be an or situation. It can't be both at the same time. It can be greater than 9, or it can be greater than 9 if you've got negatives, but either one of those will work. Okay, now what if, and so I'm going to kind of change the problem a little bit here. What if instead of greater than or equal to 9, it said less than or equal to 9? So on your number line, I want you to think about, okay, when are the absolute values less than negative or less than 9? So if I have 0 here, show me where that happens. So if I have 9 here and negative 9, when are my absolute values less than 9? That's going to happen in between. So if that's the situation, then I'm talking about an and situation because it's less than 9 and greater than negative 9. So when my numbers are between there. So if it's between, then I'm talking about and, as we've seen in the last examples. If I'm talking about either, then, greater than or less than, I'm talking about or. And so there's a way to think about absolute value inequalities. And so what we have to do, and just kind of one way to look at this, is if it says greater than, then we are talking about an or situation. If it says less than, we are talking about an and situation. And so you have to pay close attention to that. Now, for me, that was always hard to remember. I struggled remembering that. So an easier thing for me is just to test the values. So when I get the answers, I just throw in a number and check real quick and make sure that that really works. So when we do number 9, we're going to set up two equations. We're going to say, okay, 3v is greater than 9. So if this number is greater than 9, like 10 or 12 or something, then my absolute value will be greater than 9. But also if 3v is less than or equal to negative 9, that's on the other side of the number line, and that will also give me an absolute value of greater than 9. So I'm going to solve each one. And so I divide everything by 3 on both sides. And so that's what I've got on my inequalities. So now, if I didn't remember if this was and or, because you can't really, necessarily know that unless you remember the little pattern. So if I say, okay, here's my 3, so it's going to go like this. And here's negative 3, so like this. Now, if that was an and situation, then it would be no solution. But if it's or, then I have solution. So I have to stop and think. So what I would always do is I would pick a number like, 5. And I'd plug it in up here. 3 times 5 is 15. The absolute value 15. Yep, that's greater than or equal to 9. Check. Okay, so yes, those are really my solutions. They work. Okay, and then throw in something on the other end. What if that was a negative 5? What if I would have said 3 times negative 5? So it's negative 15. The absolute value is 15. Yep, that's greater than or equal to 9. So yeah, that's true too. So that's when I know that it's or. And so that's how I'll say my answer. So if you want to remember that when it's greater than or equal to, it's or. When it's less than, it's going to be smaller values, so closer to the 0, so it's going to be and. So if that's something you can remember, great. Otherwise, you can do like I always did and just plug in numbers and check, but you have to know as an and or. And if you don't remember some way to remember that, that's going to be a coin toss every time, and half the time you'll be wrong. So be really careful with that. Okay, pause the video and let's do number 10. Okay, so you should have written 1 plus b is greater than 6. So the first inequality you do is just write what it says except lose the absolute values. The second inequality, you write the first part, the part on the left, but then you switch the sign. So basically because you're doing the opposite of everything, so you're going to move or change everything to negative, so kind of like when you divide both sides by a negative. So solve each one, so you're going to get b is greater than 5, or b is less than negative 7. So when you put that on your number line, so that's or, and that's what it looks like. So if I'm confident that I've done that right, good. If this was a test or something, I would definitely throw in some numbers and just make sure, like, I don't know, pick something easy. You could pick something in the middle and make sure it doesn't work, like 0. 1 plus 0 is 1. Is the absolute value greater than 6? Nope. So my solutions must be on the other side. It's probably a safer bet to pick something on either side and try two things. Like if I tried 10, 1 plus 10 is 11. Absolute value is greater than 6. If I did negative 10, that would be negative 9. Absolute value is 9, which is greater than 6. So I just want to be sure that my and or is in the right spot. Okay, on your paper, I changed number 11 to be less than or equal to negative 4. So it didn't come through on my copy I have up here, but that's what you have on your paper. So we're going to write this two different ways. So if you want to pause for just a second, but I want you to think about what it's saying. So as you're writing, I want you to think about what you're saying. Okay, hopefully you thought about this, but what we're saying is that r plus 2, when I take the absolute value of it, it's going to be less than negative 4. Think about that for a second. The absolute value, think about what you know about absolute value, is less than negative 4. What do you know about that? When is the absolute value of anything less than negative 4? That's never going to happen. So this right here is no solution. There is no number that you can plug in that you can add to and get an absolute value less than negative 4. Like, negative 5 or negative 100. There's no absolute values that small. So that's an example of no solution. As far as your graph, you don't have to graph anything. Okay, the last one, pause it, and then we'll do this together. Okay, so when you wrote these two separate inequalities, did you choose and or did you choose or? So if you can remember, then you know which one to pick. If you don't remember, then go ahead and just solve each one and put them on the graph and then plug in values and find out. So if I multiply both sides by 3, I'm going to get k is less than or equal to 9, and I'm going to get k is greater than or equal to negative 9. So if I put those in here, okay, so if I say and, it's going to be everything in between. If I say or, it's going to be everything. So it kind of matters. So I need to make sure. So one thing you could do is you could just plug in 0. If that works, then it's going to be and. So 0 divided by 3 is 0. Is it less than or equal to 3? Yep. So it's going to be everything in between. So my solution, the way I'm going to write that is I'm going to write k is everything less than or equal to 9 and at the same time greater than or equal to negative 9. You can write it like that, or you can write k is less than or equal to 9 and k is greater than or equal to negative 9. If you're writing it like this, you have to write number line order. Okay, don't forget that you can always test your numbers like I did and see if it's right, or you can come back up here and where we said less than, it's going to be and.